Today we are discussing about discrete time signals and systems. Discrete time signals and systems. Hi everyone, today we are discussing about discrete time signals and systems DT. First one is independent and dependent variable translations, transformations. Independent and dependent variable transformations. Independent and dependent variable transformations. Time shifting or translation. Time shifting or translation. Again, time shifting is called translation. Before classes we are discussing already we discussing time shifting is a translation to convert the signals from one form to another form, either discrete to continuous or continuous to discrete. Here the maps input signals and output signals x and y. Input signal x and output signal y can be represented y of n equal to x of n minus b. Already we know. These are the time shifting translation examples. For example, just we are observing, we can change or we can translate the signals from upper to lower or lower to upper or right to top to bottom or bottom to top or left to right or right to left. So everything is possible with the help of time shifting or translation. Shifting or translation with the help of time intervals and converters to convert the signals from one form to another form or one medium to another medium. So that's why we are using time shifting or translation. Next one is time reflection or reversal. In this example we are clearly observing from below diagrams left side and right side, they are like acts as a opposite opposite reactions. One is moving to the right side and one is moving to the left side. That means by using time intervals or time reflections, that is indicating y of n equal to x of minus n. Y of n equal to x of minus n. That means the input and output. Waveforms are different. The input and output waveforms are different. So that's why we are using time reflections. The main object of time reflection is it will reflect the signals from left to right or right to left. Generally Geometrically, the output signal Y is a reflection of the input signal X about the vertical line n equal to 0. About the vertical line n equal to 0. So that means the output signal Y is a reflection of the input signal of X. So both input and output signals are different. So that's why the wave is shifted from left to right or left to right. Right to left or left to right. Next one is down sampling. Already we know what is the meaning of sampling. Already we know what is the meaning of sampler or sampling. By using sampling, it will convert the continuous time signals to the discrete signals. A continuous time signal is split into equal intervals. That means DT, discrete signal, is known as sampler or sampling. That means CT is converted into DT. CT is converted into DT. Okay. CT means continuous time signal. DT means discrete time signals. Continuous time signals and discrete time signals. Okay. In this drawn sampling, maps of input signals X to the output signals Y as given by y equal to x of an. A is a strictly positive integer. A is a strictly positive integer. A is a strictly positive integer. The output signal Y is produced from the input signal X. The output signal Y is produced from the input signal X by keeping only every 80th sample of X. So that means we are observing two diagrams, left and right side diagrams. The size of the wave, is increasing sometimes, decreasing sometimes. So that means down sampling. So down sampling, already we know the meaning. Down means decreasing. Down means decrease. So from the left side diagram, the pulse amplitude is very high compared to the right side diagram. So that means by using down sampling, it will decreasing the size of the signals. Or decreasing the amplitude of the signals. With respect to the time. So that means by using down sampling, it will decreasing or compress the given signals, and then after execute the converted signals from the output side. That is the main object of down sampling. Define down sampling. Down sampling is nothing but compressing or decreasing the given data. compressing or decreasing the given data, and then executing or process the given data. And next one is combined independent variable transformations. Combined variable transformations. Consider a transformation that maps the input signal x to the output signal y of n equal to x of an minus b, x of an minus b, where a and b are the integers and a not equal to 0, where a and b are the integers and a not equal to 0. Okay, such a transformation is a combination of time shifting, downsampling, and reversal operations time reversal operations. Such a transformation is a combination of time shifting, downsampling, and reversal operation and reversal operations. Time reversal commutes with downsampling. Time reversal commutes times downsampling. So in downsampling there is a mutual relationship between reversal commutes and downsamplings. Both are most useful are mutual relationship between data propagation in the purpose of decreasing or compressing the sampling size or sampling values or signal sizes. Okay, time reversal over. Next one is time shifting does not commute with time reversal or drawing sampling. The above translation equivalent first time shifting x by y and then downsampling the result by a, and if a less than 0, time reversing as well as. So the overall concept of combined independent variable transactions, the overall concept of combined independent variable transactions, it is mainly used to convert the signals in the form of downsampling. And next one is properties of signals. What is signal? Already we know signal is nothing but it will consist one or more variables. One or more variables is known as signal. It will carry the information includes one or more variables. Symmetry, addition or multiplication. Symmetry and addition or multiplication. Symmetry and addition or multiplication. Sums involving even and odd sequences have the following properties. Sums involving even and odd sequences have the following properties. So, for example, when we are solving any problems, we are using The sum of two even sequences is even. These are the three conditions which is used at the situation of simplifying the equations, which is used at the simplifying the equations. Sum of two even sequences is even. That means 2 these are two both are even functions, and other function 2 plus 4 is also even, or 4 plus 4 8, 4 is even, 4 is even, 8 is even. For example, 8 plus 8, 8 is even, 8 is even, and 16 is even. So sum of two odd sequences is odd. Sum of two odd sequences is odd. And third condition is the sum of an even sequence and odd sequence is neither even nor odd. Is neither even or odd. Provided that neither of sequences is identically 0, is identically 0. That is, the sum of sequences with the same type of symmetry, with the same type of symmetry also has the same type of symmetry, also has the same type of symmetry. Next, products involving even and odd sequences. Products involving even and odd sequences having the following properties. Having the following properties. The product of two even sequences is even. The product of two even odd sequences is even. The product of an even sequences and an odd sequences is odd. So this is the product of sequences with the same type of symmetry is even, while the product of sequence with opposite type of symmetry is odd. Opposite type of symmetry is odd. Next one is decomposition of signals into even and odd parts. Decomposition of a signals into even and odd parts. Even and odd parts. Every sequence X has a unique representation of the form. Every sequence X has a unique representation of the form. X of n equal to xe of n plus x0 of n, where the sequences xe and xe and x0 are the even and odd respectively. E means even, O means odd. So the unique representation form x of n equal to even function plus odd function. So that's why we are writing in particular sequences xe and x0 are given by xe of n equal to 1 by 2 x of n plus x of minus n, and x0 of n equal to 1 by 2 x of n minus x of minus n. The sequence xc and x0 are called even and odd poles. respectively. The convenience, the even and odd ports of X are often denoted as even and odd respectively. So the overall the overall concept of even and odd parities or even and odd bits, it will consist of particular particular data communication rules, which is helpful to the execution of signal transmissions, which is helpful to the execution of signal transmissions. And next one is sum of periodic sequences. Next one is sum of periodic sequences. The least common multiple of two strictly positive integers a and b denoted LCM a of b is the smallest positive integer that is individually by both a and b. The quantity LCM a b can be easily determined from a prime fractionalization of the integers a and b by the taking the product of the highest power for each prime factor appearing in these fractionizations. Example LCM 26, that is 3 power 1, 2 power 1, 5 power 1, 2 power 2, 5 power 1, 3 power 1, 3, 2 power 2, 60. So like this we are indicating or we are assigning. Next one is LCM 54, 54, 24. That is multiplying like 2 power 1, 3, 3 power 3, 2 power 3, 2 power 1, 2 power 3, 2 power 3, 260, 260. LCM 2490 equal to 360. So these are the different techniques. These are the different techniques which is used for some periodic sequences. And sum of periodic sequences. For any two periodic sequences x1 and x2 with the fundamental periods n1 and n2 respectively, the sum x1 and x2 is periodic with period LCM n1 and n2. So for any two periodic sequences x1 and x2 with the fundamental periods n1 and n2 respectively, the sum x1 and x2 is periodic with period LCM n1 and n2. Next one is right-sided signals. Right-sided signals means the signal propagation is moves from right-sided. So that's why it is called right-sided signals. A signal X is said to be right-sided if some finite integer constant n naught, the following conditions hold. X of n equal to 0 for all n less than or equal to n naught. X is only potentially non-zero to the right of n naught. An example of right-sided signals is shown below. It is the signal increase the wave or increase the samples from -1, 0, 1, 2, 3. That means it will move forward to the right sided. That's why it is called right sided signals. A signal is said to be actual if x of n equal to 0 for all n less than or equal to 0. For a casual signal is a special case of a right-sided signal. A casual signal is not to be considered with a system in these two contexts. The word casual has very different signals. Left-sided signals compared to the right-sided signals. Left-sided signals are increased positive side to the negative side. Positive side to the negative side. 1 0 minus 1 minus 2 minus 3 minus 4. That means it will exactly performing reverse operation of right sided signals. Right sided signals are moves from the left to right, and left sided signals are moves from the right to left. So both are opposite reactions or opposite performances. To execute propagates the data information from one place to another place. Next one is finite duration and two sided signals. A signal that is both sided or right side or left side said to be finite. That means signal is occupying the uh, place as pass band place from right left sides are known as finite state. Finite means it will occupies, it will transmit the signals both right and left sides. That's why it is called finite. Two-sided signals. Next one is two-sided signals. Two-sided signals means a signal that is neither left side or north side is said to be two-sided. And two-sided are represents like a mirror reaction. It will oppositely executes from left to right or right to left. So these are the different operations and different conversion techniques. All are used to more helpful to convert the signals from one form to another form, from one form to another form. That's why we are using different signal conversion techniques to execute or propagate the signals from the output side. Okay, thank you.